Hello everyone, welcome to this video. In this video we'll be solving this question which states that we have to find the element A and the element B from some group which is not known to us. We have to find an appropriate group such that the order of A is equal to the order of B and it is equal to 2. Right, and moreover the order of AB in the first case it should be 3, in the second case it should be 4, and in the third case it should be 5. Right, so let's start with this question here. So in this question we have already learned about dihedral group, right? Let's take them here also. Now the dihedral group Dn gives you the symmetry of a n-sided polygon, regular polygon. Now there are n rotations within it which are represented when you divide 360 with n, you get the lowest angle, and the others are multiple of 8, and there are n reflections within it. Let's call them Fi, correct? Now we also know that in any dihedral group, if we compose any two reflections, the result is a rotation, right? Because we have already discussed this thing in the previous videos, that if you associate reflection with that of negative sign and rotation with that of positive sign, right? So negative and negative give you positive, so therefore we have this result. And moreover you have either reflection into rotation, right? That would definitely give you reflection. You can associate it with like this is negative, this is positive, negative and positive would give you negative, correct? Similarly the other way around, rotation into reflection is a reflection, and rotation into rotation is what? It is a rotation only, correct? So that any two reflections, they give you rotation, and the order of each reflection is 2. Why? Because when you apply the reflection twice, you will get back the same result. So therefore we obtain A and B as two reflections from Dn, such that when you compose them you would have a rotation, and we have to see the rotation, which rotation has order 3, which rotation has order 4, and which rotation has order 5. So clearly for different cases we have to consider different dihedral groups. In the first case we will be considering D3, the dihedral group of order 6, right? So this give you the symmetries of triangle, equilateral triangle. Here if we take the rotations as R0, R120, R240, and the reflections as F1, F2 and F3, then in that case you see, if you take any two reflections, let's call it F1 and F2, right, and calculate their orders, the orders come out to be equal to 2, and when you compose these two reflections here, what do you get? F1 into F2. F1 composed with F2 give you R120, which is a rotation, right? And what is the order of this rotation? It is 3. Why? Because when you compose R20 thrice, what do you get? You get R120 into R120. It is here, it is R240, right? And R240 into R120, R240 is here, into R120, it would give you R0, which is the identity of the group. Hence the order is 3, right? So we are done with the first case. In the second part we consider the dihedral group D4. In this dihedral group D4 we have 4 rotations and 4 reflections, which are represented by R0, R90, R180, R270. Then the horizontal reflection, vertical reflection, reflection along the main diagonal and along the other diagonal. So here we take any two reflections. Let's take the horizontal and vertical reflections. Let's take the horizontal and the diagonal reflection. Both of them have order 2 because both of them are reflections, and when you compose them, H into D, right, from the scalar table you can see H composed with the D would give you what? R90. And what is the order of R90? It is 4. Why? Because R90 into R90 4 times. R90 into R90 is R180, right? Both of them, they give you R180, and both of them here give you 180, R180. hence you have R0 here, because R180 into R180 is R0, hence this is the identity. So here we also obtain another example. In the third part, we obtain an example of the group D5. What is this group D5? It consists of 5 rotations and 5 reflections, where you obtain the rotations like this. Why R72? Because when you divide 360 by 5, you get 72. So the first rotation is by 72 degree, the other one would be by 144 degree, 216 degree, 288 degree, and then we have 5 reflections, right? Reflection along this vertical line through 2, through 3, 4 and 5, like this, right? So therefore in this case, let's take any two reflections. Let's take the first and second reflection, F1 and F2. Both of them have order 2. Why? Because when you perform the reflection twice, you get back the same thing. And what is F1 composed with F2? It is R144. You can clearly see from here why it is R144, because when you first apply it, now on this figure you have to apply this composition. What is this composition? That means you have to reflect it along this axis. So when you reflect it along this axis, 5 would remain 5, 1 would become 4, and 4 would become 1, this 3 would become 2, and this 2 would become 3. So therefore in this case, this match with what? It match with this R14, hence the composition is R14, right? Now we have to look for the order of R144. So you see, when you perform when you compose R144 with itself 5 times, you get R0. How? Let me show you. R144 into R144, so that means you have to do this thing on R144, right? So what will you get? You see, what is the change from here to here? The change is that we have shifted our system anti-clockwise 2 units, right? So that means we have to shift the system anti-clockwise 2 units as well. So 4 would go here, 1 would go there, right? 3 would go at place of 5, 5 would go at place of 2, 2 would go at place of 4. So what is the figure here? That is 288. Similarly for these two you obtain 288. Similarly for these two you obtain 288, and R144 is left behind. Now let's see what is R288 into R288. So this is your R288. We have to apply the same operation on this R288. So first of all, let's identify what is the difference between R0 and R288. So you see, this R288 is nothing but this shifted 1 unit in the clockwise direction. So basically we also have to do the same thing. We have to shift this 1 unit in the clockwise direction, so that we would have 2 here, 1 here, right, 5 here, 4 here and 3 here. Now what is this figure? You can clearly see this is the figure R216. Hence you have R216 in place of this R288 and R288, correct? Now when you compose R216 with R288, so that means you have to compose both of them. What result do you get? So first of all, you have this figure. Here in this figure, what is the difference here? What operation is performed here when you move from R0 to here? We saw that we have moved 1 place to the right, right, in the clockwise direction. So that means here also we have to move 1 place to the right. So it would be 3 would come to the position of 2, right? So here we would have 3, here we would have 2, here we would have 1, here we would have 5, and here we would have what? 4. This is the operation that we perform. I am sorry, what I did, I performed 216 and R288. Instead of doing that, we have to do R216 with R144. So let's do it again. So R216 is this one, right? This you know, and R144 is this one. Now here on R144, what is the difference between R0 and R114? Here you see this has been shifted to 2 place in the anti-clockwise direction. This is what has happened. So that means in the figure 216 we have to shift this thing to 2 place in the anti-clockwise direction, so that this 5 would become 3 now. 5 would go to the place of 2, 2 would go to the place of 4, right? 4 would go to the place of 1 and 1 would go to the place of 3. So which figure is this? You see, this is R0, hence your answer is R0. Hence the order of R144 is 5 here within this group D5. You can also construct the Kelly table for D5 for easier calculation, right? So I hope you understood this question well. Well, that is it for this video. Thank you for watching.